Hi, welcome to the lab demonstration on basic CLI operations and stacking with Ruckus ICX switches. In this video, I'll demonstrate how to navigate the Ruckus command line interface, or CLI. We'll talk about the differences between the running configuration and the configuration file. I'll display how the primary and secondary image files can be used on the switch. And finally, we'll demonstrate how to build a stack using 3 ICX switches. But first, let's talk about the CLI itself. When you first log into a switch, you'll be in the user exec mode. This is shown by the greater than sign at the end of the prompt. These switches have just some basic configurations put on us for just to be ready for this lab exercise. We put a host name on the switch. We've disabled all the interfaces because it's in a complex lab environment. So there'll be some things as we go through it that'll already be set up for us, but that's okay. I'll talk through those as we go through the exercise. So in user exec mode, you're very limited on what commands and what you're capable of doing. In this mode, you can access the privileged exec mode with the enable command, and you can do some connectivity testing with ping and traceroute, and then you can show information in the switch. So this is basically a read-only type level of the CLI. So if we want to make any changes to the switch, we have to get into the enable or privileged exec mode, and we do that with the enable command. Here I don't have any password set on the switch yet, so the system will let us know that there's no password assigned and there's really no security. This is what the default state of a switch is when you first power it up and start plugging in and making configuration changes. So once I'm in enable mode, you saw when I typed the question mark in user exec mode, we only had a couple options available to us. So the question mark tells us which commands we can use. We have a long, lengthy list of commands here that are available to us now that we're in privilege exec mode. When you're in this, you can press the space bar to go through another page of commands that are available to you. If you press the enter key, it'll go up one line at a time showing you available commands. There are also some other features of the CLI that's available everywhere. You can type just a letter of a command followed by the question mark, and it'll tell you which commands start with that letter and what are available to you. It's a nice way to kind of just filter out a lot of the noise that shows up when you run the question mark by itself and only show you commands related to whatever it is you're thinking you want to get to. Sometimes when you can't remember a command, this is a very helpful tool to have. You can also go a step further and type 2 letters, and it'll only show you the ones with those two. As soon as you get to the point where you've uniquely identified a command, you can press that. You can press the tab key, and it'll actually fill in that command for you. So with CON, the only command available was the configure command. Now, if I press the question mark here, you see there's only one option after configure, and that's terminal. So you can also press just the tab key here, and it'll autofill the next available option for this command. When there are multiple options, you have to do the same thing. You can type a couple of characters and have it autofill for you. Now, knowing that you can do this, you can also shorthand a lot of these commands. So once you've uniquely identified the command, so we know conf is enough for configure, so I can just end with conf, put a space and a question mark, and it says terminal's next. Well, since terminal is the only option, I can just type T and hit return, and now I'm in the configuration terminal mode that allows me to actually make configurations to the switch. So this is where the point you want to get to actually start making changes to the switch and to the device. So now that we're in configure mode, let's take a look at some of the other things that happen to the prompt when you're in configuration mode to kind of tell you where you are in the system. So if I go to interface Ethernet, if I could type Ethernet, we'll go to 1/1/2. So the prompt changes to show that we're in the interface configuration context, and from here I'll hit the question mark again. We have several commands available to us to configure the interface. So this is all hierarchical. You'll step down through the system and make changes, and the prompt will change along with you as you do it. So if I press quit here, Control C or Q, it'll take me out of this back to my configuration prompt, and I can actually make changes here. So let's take a look at what we have configured on the switch right now. So I'm going to do, and we can type show commands from any context on the switch, which is a nice feature. You don't have to back out of configuration mode to run show commands. So I'm going to take a look at the running config, and what we see here is this is the configuration that the switch is operating under right now. Um, that's a very important distinction, and I'll explain what that distinction is as we go through. But right now, this is the configuration that the switch is actually operating under. So here we have just host name and all the interfaces, and they're all disabled. So they show up here as disabled because I've explicitly disabled all of these ports. Now, if these ports, well, actually, let's show you. I'm in interface 1/1/2, so you can see here, I'll highlight it for us in the running config. 112 is disabled. Well, I am going to enable it, and we'll take a look at what that does to us. So we'll do the show run again. This is the show running config. I like to type short versions of these commands because my typing skills are lacking, and it keeps me from making mistakes and having to backspace too often. So we'll look at the running config, and here you see we go from interface 1/1/1 to interface 1/1/3. So the default state of an interface is enabled, and the switch configuration will not show things that are set to their default values. They only show configuration settings that deviate from the default values. So in the running configuration, the operating configuration of the switch right now, we see the interface 112 is not in this list as disabled, therefore it's enabled. Well, let's take a look now at the configuration file. So this is the show config command. This is the file that is looked at when the switch boots to set up the operating parameters for the switch. So in the show config, we look and we still see interface 112 is disabled. So I've changed the operating conditions of the switch, but I haven't changed the configuration file that the switch boots from. So if this switch were to reboot right now, when it comes back up, interface 2 would be disabled again, even though we've gone through and enabled it here. So how do we make sure that what we do in our operational config is copied over to that config file? Let's get out of here, and we can run the write memory command. So when we run that command, we are writing what is in memory, which is the running config, to the configuration file, so that when the switch boots, it'll boot up with these parameters. So we get a confirmation. It's writing to the startup config, and that copy from the memory to the startup config is completed. So now, if we look at the show config, we'll see interface 222 is not listed because it's in its default state of being enabled. Okay, so we've looked at how configuration changes are applied, how the running config is the operating parameters that the switch operates under at the moment, and the startup configuration file is the file that is looked at on boot to have the switch boot up into the proper configuration that you would like it to operate under after a reboot. So that's helpful because sometimes you want to, make some changes potentially, see how they work before you save them to the startup configuration file. So the other thing about these switches is they have two flash storage locations, a primary and a secondary flash location. These are used to store the type of image or firmware that's loaded on the switch. These ICX switches can operate as switch mode, running switch code that does layer 2 functionality, spanning tree, things like that, but it won't do any routing, so you can't assign multiple IP addresses to multiple interfaces or anything like that. For that, you need the router image. So let's take a look at our flash. So in our flash, we've got a primary code and a secondary code. The primary is the SPS for these 7250 switches. The SPS, the S, that third character, says that this is switch code. So in the secondary, we have the SPR version 8.0.30H, and the R signifies that this is router code. So right now, we can tell which one we're operating under with the show version command. So show version command gives us output that tells us which code we're running from. We booted from the primary, and we're operating with the SPS, so the switch code. So this device is running switch code, but it could run from router code as well. So a couple things we can do with this. There's a command, the boot command, boot system flash. So I can run this command right now in the privileged exec mode, and if I type this command as is and run it right now, it will want to boot up to that secondary flash. I don't want to do that right now, so I'm going to say no here, but that one has an immediate reaction and boots the switch. So the boot command, when executed right next to the # prompt when you're in privilege exec mode, will reboot the switch to whatever flash you want to boot from. But now, let's say I want my switch to boot up on the router code on the next reboot, and I don't want to change which file is in the primary and which file is in the secondary. I just want to tell my switch to boot from the secondary the next time it boots. Well, for that, we have to get into the configuration mode, right? Because we have to change the configuration and then save it to the startup configuration for that to happen. So when you're in the configuration context, you can run the boot system flash secondary command again, and this will put it in the configuration for you. So now, rather than immediately forcing the switch to reboot to the version you want, you can tell it on the next time I reboot, this is what I want it to do. We'll do this at a couple points in some other demonstrations I'm going to show you, because we're going to want to be in router code. All of these switches have switch code in the primary, router code in the secondary, and when we're doing lab exercises for routing protocols, for example, we will want it to boot from the secondary. So again, what we just typed is written to the running configuration file. Right? We see it in the running config, but it is not in the regular configuration file. See here in the running config, it goes right above the host name, but in the startup configuration, it's not here. Why not? Because we haven't done a write memory yet. So now it's there, and if we do the show config again, we see that bootsys flash secondary comes up. So when the switch reboots, it's going to look into this configuration file, and it's going to say, whoa, I'm supposed to boot from the secondary flash, not the primary, which is the default, and it'll boot up in the router code for us. Okay, so let's configure stacking. Stacking is a way of combining 3 separate switch units to act as a single unit, and we can do that with these ICX switches. So what I have here is I have 3 switches, 3 separate tabs. Each one is connected to the console of each of these 3 switches so that I can configure stacking on them. I'm going to do the demonstration. I'm going to configure unit 4, which is the one I'm in right now. Configure all the stacking settings on unit 4. We'll go through the motions of doing that configuration and saving it, and the process to enable stacking. On the other 2, the configuration commands have already been pushed to it rather than watch me type them in 3 times when they're all the same commands for all 3 of these devices. It is just a bit of a waste of time of yours and mine, so you don't want to sit and watch me type and make mistakes over and over again 3 different times running the same command. So those 2 are ready to go for us, but we'll walk through on unit 4 all the configuration steps for these particular switches, and we'll enable stacking here. So we're going to stack these units using ports 1/2/1 through 1/2/4. So these are the, on this particular switch, the ICX 7250, these are the ports on the front, the 10 gigabit Ethernet ports on the front of the unit, and we're going to be using those to provide our stacking. We're going to use trunks, so we're going to use 2 10 gig ports from unit switch 3 to switch 4, and then a connection from switch 4 to switch 5 using those two 10 gigabit trunks as well. So let's go ahead and start this configuration. So we're already in configuration mode. So first we need to set up stacking and let this unit know that it's going to need to function as a stack. So we do that with the stack unit command. So stack unit 1, the start unit. Now here we define, depending on which switch, you're going to define the default ports that are used for stacking. We're doing this on a 7250. The default ports are ports 121 and 123, so this command on this particular switch model is unnecessary. On other switch models, like the 7450, the rear ports are the default ports, and if you wanted to use the front ports for stacking, you would have to execute this command. So I'm going to go ahead and run it, even though it's unnecessary here. Default ports on this is 1/2/1 and 1/2/3. So it'll tell us that these are already the default ports. That's fine. Didn't hurt anything. Just want to show you the command that is used to do this. So like I said, we're going to configure this to use trunks, so two 10 gig links between each unit so that we have more bandwidth in the stack. So we'll use the stack trunk command for this, and we are going to use 1/2/1 to 2. So 1 and 2 are going to be bundled together as a trunk, connecting to the next downstream unit. We'll run this command again. I'll just do the up arrow and fix some things. 123 to 124, so that's our second trunk. One trunk will go to switch 3 from here, and then the other trunk will go to switch 5 from here. So now, like I said, all of these interfaces are disabled because this is the way we do it in our lab, just to keep, there's multiple connections between all the switches, so this just, having all the ports disabled ensures that we don't create any loops in the lab environment. So we need to enable all these ports. Okay, so enable, and they are now up. And we'll write to our to our startup config and have this saved. We're going to go and document a couple of things on each of these switches. So we'll get into enable mode. Actually, I didn't need to do that. We're going to show interface 1/1/1. Okay, we're going to show the interface information and collect the MAC address. So in this output, the MAC address of that port is this address here. I'm just going to document the last two characters, 60, that's unit 3. Okay, let's go to unit 4. And we'll use the brief command here to note that command. So that one's 00. I might want to write down the Charlie 00 just for that one, just in case the other one ends in a 00 as well. And let's get into unit 5. And that one is 3 Charlie. So unit 3 had a 60, 4 ended in 00, and 5's MAC address ended in 3 Charlie. This will be important to us. You'll see why this is important to us after we configure stacking. So we're going to start building our stack from unit 3. So from unit 3, we run the stack enable command. Okay, so this sets up stacking. This says enable the stacking functionality, and that this unit can actively participate in a stack. So by doing this, by setting those front ports to stacking ports, that means that optical monitoring for those ports has to be turned off. That's just a functionality thing that when you enable stacking on this unit, you have to sacrifice the ability to do optical monitoring on those interfaces. Okay, so we can exit out of here and we start the secure setup process. And this is what actually goes through and analyzes the units, analyzes the topology, sees which units are there, and builds the stack. So this says I've identified 2 other units out here. They're 7240s. One of them has a MAC address of 00. That's the one for switch 4, and that's why we noted that MAC address. And switch 5 is 3 Charlie. So we don't list our own because switch 3 knows who it is. So now it's trying to determine if you want all these units that it found to be a part of the stack. So we do. So we're going to enter 2 here. This is the number of upstream units, and the stream is just a perspective thing. It's still a stack either way, but these are all identified as upstream switches. So we want both of them. The one that's 1 hop away, how many links do we want to have to it? It found 2 cables. We can do it with 1 link or 2. We did enable them as stack trunks, so we want to use 2 ports, 2 links between them. And we want 2 links to the next switch as well. So this just overview says, okay, these are the devices. We are on switch 3. It was given an ID of 1. And switch 3 we know is the one with the MAC address ending in 60. It's going to give ID of 2 to the one ending in 00. That's our switch 4. And the stack ID of 3 is going to go to the one that ends in 3 Charlie, which is our switch 5 up here. So do we want to accept these? Yes, we will accept these changes and return. And now we'll watch this system go through and actively build out the stack. So here we can run the show stack command. So we see all of our members. This one's active. They were dynamically configured. Unit 1, because the one we run the secure setup process, it's static. The other ones are dynamically configured because they were found by the static unit. And then we see this little graphic here that tells us how these switches are all connected together. So port 2.1 and 2.2, it just doesn't have enough space to display that, connects to from unit 1 to 2/3 on unit 2, and 2/1 on unit 2 connects to 2/3 on unit 3. So we have a linear stack here between these 3 devices. Okay, so as I said, once we run this as a stack, all the port numbers and everything change based on the unit's ID. So if we do, and let's try that again. If we run the show interface command, we'll see that we have a lot of ports here. So all of unit 1's ports are the 1/1/ up to 24. All these here are unit 2 ports. And notice that because it defaulted these units, all the ports are in their enabled state. So this gives you a chance to actually see that we do have several things interconnected in my lab environment that are all coming up and operational, and potentially creating a loop in my lab environment, but that's okay. It's sealed off from the rest of the network, so it won't really cause any problems for us. And then we get to unit 3. 3/1 are all the main front interface ports, and then the 3.2.1 and through 3.2.8, 2 of those are used for our stacks. Okay, so we have a complete stack here. Everything is operational. We have some other commands that we can show that give us details about our stack. So we can run the show stack neighbor command, and we can see how all these devices interconnect to each other. Which ports connect where, which ones don't connect to anything, and it just gives us all the information about our stack. And then the show stack ports command shows us that same image of the active unit, standby unit, which ports are connecting them, which stack ports are up, which stack ports are down, and details about all of those interfaces. So the stack is fully operational. Now let's say you get to a point where you have this operational stack, and because Unit 2 and Unit 3 are dynamic devices, um, they don't have proper config and you want to undo the stack. Well, we can do that as well. So we're going to do that and kind of get things back to our clean slate for future demonstrations. But to remove the stack, or disable all that functionality that we've gone through all the steps of enabling, we can go into switch 3, which we're already in as the active device, and we can run the stack unconfigure command. So we'll unconfigure all of them. Gives us a message letting us know we'll dismantle the entire stack, and it'll go back and actually go put switches, the second two in the stack, back to their pre-stacking startup config. So when these go back, they'll actually maintain that old configuration file they had, and they'll boot back up to that file. So all those interfaces will be disabled again like I like them. So we remove the stack enable from all of them. It deletes the unit configs, and these things will all fall right back to the state they were in before we started. Okay, well, this concludes the demonstration on stacking and basic CLI commands. We learned a few things about the CLI, how we can do abbreviated commands, how we can use the question mark to find out configuration options under a command. We saw the prompt changing based on where you are in the configuration hierarchy of what it is you're configuring. How to navigate out from those different branches of the CLI hierarchy. We talked about some of the differences between the configuration files. We have the running configuration file, which is the operating conditions of the switch, live at that time, and the startup configuration file, which is the file that's used to set up the configuration when the switch reboots. We also talked about the two different flash locations, the primary and the secondary. In ours, again, we have switch code in the primary and router code in the secondary, and how we can boot to one of those flashes either immediately or set it on the next reboot. To set on the next reboot, we do that from the configuration context. So hopefully you've learned a little bit about the basic operations of the CLI, got to see how stacking it operates, and I'll see you back for some other demonstrations later in the course.